Imagine you are a part of a crew of astronauts traveling to Mars or some distant planet. The travel time could take a year or even longer. The space on board and the resources would be limited. So you and the crew would have to figure out how to produce food with minimal inputs. What if you could bring with you just a few packets of seeds and grow crops in a matter of hours? And what if those crops would then make more seeds, enabling you to feed the entire crew with just those few packets of seeds for the duration of the trip? Well, the scientists at NASA actually figured out a way to do this. What they came up was actually quite interesting, and it involved microorganisms, which are single-celled organisms. And they also use hydrogen from water. The types of microbes that they used were called hydrogenotrophs. And with these hydrogenotrophs, you could create a virtuous carbon cycle that would sustain life on board a spacecraft. Astronauts would breathe out carbon dioxide. That carbon dioxide would then be captured by the microbes and converted into a nutritious, carbon-rich crop. The astronauts would then eat that carbon-rich crop and exhale the carbon out in the form of carbon dioxide, which would then be captured by the microbes to create a nutritious crop, which then would be exhaled in the form of carbon dioxide by the astronauts. So in this way, a closed-loop carbon cycle is created. So why is this important? We need carbon to survive as humans, and we get our carbon from food. On a long space journey, you simply wouldn't be able to pick up any carbon along the way, so you'd have to figure out how to recycle it on board. This is a clever solution, right? But the thing is, that research didn't really go anywhere. We haven't yet gone to Mars, we haven't yet gone to another planet. And this was actually done in the 60s and 70s. So a colleague of mine, Dr. John Reed, and I, we were interested actually in carbon recycling here on Earth. We wanted to come up with technical solutions to address climate change. And we discovered this research by reading some papers published in the 60s, 1967, and later articles about this work. And we thought it was a really good idea. And so we said, well, Earth is actually like a spaceship. We have limited space and limited resources. And on Earth, we really do need to figure out how to recycle our carbon better. So we had the idea, can we take some of these NASA-type ideas and apply them to our carbon problem here on Earth? Could we cultivate these NASA-type microbes in order to make valuable products here on Earth? And we started a company to do it. And in that company, we actually discovered that these hydrogenotrophs, which I will actually call nature's supercharged carbon recyclers, we found that they are a powerful class of microbes that had been largely overlooked and understudied, and that they could make some really valuable products. And so we began cultivating these products, these microbes in our lab. We found that we can make essential amino acids from carbon dioxide using these microbes. And we even made a protein-rich meal that has an amino acid profile that's similar to what you might find in some animal proteins. And we began cultivating them even further, and we found that we could make oil. And oils are used to manufacture many products. We made an oil that was similar to a citrus oil, which can be used for flavoring and for fragrances, but it also can be used as a biodegradable cleaner or even as a jet fuel. And we made an oil that's similar to palm oil. And palm oil is used to manufacture a wide range of consumer and industrial goods. So we began working with manufacturers to scale up this technology, and we're currently working with them to bring some of these products to market. We believe that this type of technology can indeed help us profitably recycle carbon dioxide into valuable products, something that's beneficial for the planet, but also beneficial for business. But that's what we're doing today. But tomorrow, this type of technology and using these types of microbes actually could help us do something even greater if we take it to the next level. So we believe that this type of technology can actually help us address an issue with agriculture. And allow us to create a type of agriculture that's sustainable, that will allow us to scale to meet the demands of tomorrow. And why might we need a sustainable agriculture? Well, actually, it is estimated that the population will reach about 10 billion by 2050. And we're projecting that we will need to increase food production by 70%. In addition, we'll need many more resources and raw materials to make consumer goods and industrial goods. So how will we scale to meet that demand? Well, modern agriculture simply cannot sustainably scale to meet that demand. And there are a number of reasons why. And one of them is that modern agriculture is one of the largest emitters of greenhouse gases. In fact, it emits more greenhouse gases than our cars, our trucks, our planes, and our trains combined. Another reason is that modern ag simply takes up a whole lot of land. We have cleared 19.4 million square miles for crops and for livestock. What does that look like? Well, that's roughly the size of South America and Africa combined. And let me give you a specific example. In Indonesia, an amount of virgin rainforest was cleared totaling the size of approximately Ireland between 2000 and 2012. Just think of all of the species, the diversity that was removed in the process, whether plant life, insects, or animal life. And a natural carbon sink was also removed. And so let me make this real for you. This clearing happened primarily to make room for palm plantations. And as I mentioned before, palm oil is used to manufacture many products. In fact, it is estimated that over 50% of consumer products are manufactured using palm oil. And that includes things like ice cream, cookies. It includes cooking oils. It also includes detergents, lotions, soaps. So you and I both probably have numerous items in our kitchens and our bathrooms that were manufactured using palm oil. So you and I are direct beneficiaries of removed rainforests. So modern ag has some problems, and we need solutions if we want to scale sustainably. So I believe that microbes can be a part of the answer, and specifically these supercharged carbon recyclers. These supercharged carbon recyclers, like plants, serve as the natural recyclers in their ecosystems where they thrive. And they thrive in exotic places on Earth like hydrothermal vents and hot springs. And in those ecosystems, they take carbon and they recycle it into the nutrients needed for those ecosystems. And they're rich in nutrients such as oils and proteins, minerals, and carbohydrates. And actually, microbes are already an integral part of our everyday lives. So if you enjoy a glass of Pinot Noir on a Friday night after a long, hard work week, then you are enjoying a product of microbes. If you enjoy a beer from your local microbrewery, a product of microbes, or bread, or cheese, or yogurt, these are all products of microbes. But the beauty and the power associated with these supercharged carbon recyclers lies in the fact that they can actually produce in a matter of hours versus months. So that means we can make crops much faster than we're making them today. They grow in the dark, so they can grow in any season and in any geography and any location. And they can grow in containers that require minimal space. And we can get to a type of vertical agriculture instead of our traditional horizontal agriculture that requires so much land. We can scale vertically and, as a result, produce much more product per area. If we implement this type of approach and use these carbon recyclers, then we wouldn't have to remove any more rainforests to make the food and the goods that we consume. Because at a large scale, you can actually make 10,000 times more output per land area than you could, for instance, if you used soybeans, if you planted soybeans on that same area of land over a period of a year. 10,000 times over a period of a year. So this is what I mean by a new type of agriculture. And this is what I mean by developing a system that allows us to sustainably scale to meet the demands of 10 billion. And what would be the products of this new type of agriculture? Well, we've already made a protein meal. So you can imagine something similar to a soybean meal, or even cornmeal or wheat flour. We've already made oils. So you can imagine something similar to coconut oil, or olive oil, or soybean oil. So this type of crop can actually produce the nutrients that would give us pasta and bread, cakes, nutritional items of many sorts. And furthermore, since oil is actually used to manufacture multiple other goods, industrial products and consumer products, you can imagine being able to make detergents, soaps, lotions, etc., using these types of crops. So not only are we running out of space, but if we continue to operate under the status quo with modern agriculture, we run the risk of robbing our progeny of a beautiful planet. But it doesn't have to be this way. We can imagine a future of abundance. Let us create systems that keep planet Earth, our spaceship, not only from not crashing, but let us also develop systems and ways of living that will be beneficial to the lives of ourselves and the 10 billion that will be on this planet by 2050. Thank you very much.